Hello everyone, this is Sojang Kim. Today we are going to use Arena simulation software. If you go to the classroom, actually you can see the link to download the software. So if you go to the notice page in a class, and actually you can see the download link from this page. Here's the link for the 32-bit OS, and then another one is a 64-bit OS. And then I guess most of you can just click this download link so that you can get the file. If you click it, and then basically the link directly goes to the Arena simulation page so that you can download the file like this. But it will take time because it has about 1.3 gigabyte. So that's why I will cancel it. Okay, I have one already. And if you don't like it, and basically you can Google it, Google the Arena simulation student edition. And technically it is just a regular edition, but you need to type the student when you install it. So Lockwell Automation is a vendor to provide the Arena simulation software. If you click it, and you can go to this Arena download page. Due to my location, you can see the Korean here. But if you just click this download free trial, and then you can type your information basically. Yeah, if you click this download button, and then you can download the software. Yes. So here's the explanation about the Arena software in academic, so education version. So if you look at it, it can do everything actually that you want. So this is a hospital model, and this is a mining model, okay, like this. So if you use a nice actually figure behind the in the simulation, and you can see the nice graphic. Right, but anyway, you can play with it and to see what kind of capability the Arena has, and capability actually the involved in the Arena software. All right, let me go back to the Arena page. So yes, please take your time and download software and then run the Arena. So if you run it, and basically you can type the Arena like this. So if you click this, and basically you are able to run the Arena simulation software. So I already opened the software like this here. And if you look at it, we have a panel, project bar, left side, and then on the left side, and then on the right side you have an animate bar here, and here is a tool. All right. So as a first as for your first modeling, we will develop the very simple model. Okay, so if you look at this, we have a data module like this, and basically the role of this module is to provide data, or set the data which will be used in the simulation model, and then you don't have to worry about this module actually right now. And next one is a discrete processing. So we are going to mainly use these modules. Okay, so we have a sign module, a sign attribute module, clean module, delay, and so on. And today we are going to use only three modules to develop the basically to develop the simple process. Let me open the slide so that I can give you the better idea about the model, simulation model. So last time we have learned about the sample path analysis, right? And here, if you look at it, we have one queue drill press and drilling center basically. We with the one drill press here, and the part comes in initially, and there is a queue, right, waiting for the service. And once part is processed, and it will depart the system. so which is a drill center. All right. So as you can see, this is very simple queuing model and simple system. And here we are going to develop this simulation model. All right. I think this is a good page to show you how the result will be. And here is the developed simulation model. Okay, layout, but it is developed by the old simulation arena version, so the shape will be slightly different. All right, let's go back to our model here. So yeah, please open the arena simulation software and then put the create module, which will generate the entities. And also next time, and you can also put the process module, right? And then you can also put the dispose module like this, right? So dispose module will terminate the entities. So whenever part or entity finish each service, and then it will be disposed, right, or terminated. So if you double click the create module, and then you can see that this pop-up window, and here is the name of the create module, and you can change each name if you want it, but I will keep it. And let's type part. And type part, yes. And then it will be generated every 1 hour with the mean of the, so you will the time interval between the part arrival or entity arrival will follow the exponential distribution with the mean of the 1 hour. Okay, if you don't like it, we will choose let's just keep it the 1 hour. All right, and then here entity per arrival means that whenever event happen, arrival event happens, and how many entities will be arrived. So initially, yeah, it is 1, but if you put 4, then 4 entities will arrive whenever arrival event happen. Okay, happens. So we will put 1 instead of 4, and max arrival will decide how many entities will be generated by this create module, and usually it is infinite. All right, and first creation of which means arrival time of the first entity. So usually it is 0. All right, so here we are going to use. So anyway, we are going to change only this entity type. And if you click OK, and then you can close the pop-up window. All right. So whenever you click the module, you can also see the relevant data set here. So if you look at it here, we have a create 1, right? So and then parts and random exponential distribution and 1 hour. So these are the parameter of the create module here. So if you double click it, you can change the value through this pop-up menu, or you can just change the value from this menu as well. All right? Yes. And then if you go to the process module, and if you double click it, you can also see this pop-up window. And here, if you want it, instead of process 1, we can also change its name to drill press or drilling center, right? Was it? Drilling center, right? So you can put the drilling center and also the action. So type is standard. We have other types, but you can just use the standard. If you want to have a sum model through this process module, you can choose a sum model, but don't do that right now. So choose the standard. And here we have 3 different actions, which are the delay, cease, delay, release. So please choose the cease, delay, release. What does it mean? That whenever part enters this process module, it will seize the resource and then spend some time, which is delay, and then after the time, it will release the resource. Once entity seizes resource, and then definitely after the survey, it should release the resource. Otherwise, other entity cannot seize the resource. So available resource should be addressed as well. So click add button here. And here we have resource, and resource name will be drill, right? And capacity of the drill is 1. So we have only 1 drill. What drill press? Instead of drill press. Yes, let's type drill press. So we have 1 drill press. Click OK. And So here is the resource. So whenever parts enter this module, it will see the 1 unit of the drill press, and then spend some time here, right? And then release the drill press. So time, so service time should be defined by this area. And here we will, service time will follow triangle. Let's say it will follow triangular distribution with the, and then only takes the 30 minutes. So here we can put 30 minutes, and then triangular usually has a minimum value as a maximum value. So let's put 20 minutes, and then let's put 40 minutes. Okay. So entity will spend between 20 and 40 minutes, right? As each service time, and click OK, right? So here is a report, here is a dispose module. So basically you don't need to do anything for this, basically, all right? And it will automatically collect the tally statistics for you. Okay, so next one. You can also add animation as well, right? So here we can add a chart, and let's add a plot here, plot chart, and click add button so that you can have a data series. And here, if you look at it, so this is a data name, so series 1. If you want to change the name, let's say what will be the number of parts in system, part in Q. Okay. And what about system? Yeah, number of system. Yes, number of parts in the system. And expression. So if you click this button, you can click the build expression. So basically, this builder, expression builder, will help you to create the command actually for you. So we are going to check the number of entities, right, in the system. Entity type, parts. So if you use this one, and technically you will check the number of parts in the process. But also here, you can also check the resource area at the menu as well. It will calculate the cost, state, usage as well. So utilization can be calculated through this menu. And process, yes. And process module. So instead of use this one, let me just choose this number in process. Okay, WIP and drill center. So that we can check the number of entity in this process module, right? Drill center. You remember the name of this process, right? So click OK. And here, if you look at a pattern, we will fill the color. So if you want it, you can fill the color like this. And back color, yes, we can use just default setting. And style solid left, point to point, no, stairs, so that we can see this kind of shape here over the time. And click OK. And you can, if you drag and drop the chart, and you can draw the chart, the graph like this. Okay. And also, we are going to put the resource as well, because we have a drill press and we want to have an image here. So usually the resource has four different states. One is idle, which it means that no one uses this resource. Busy, yes, if part sees this resource, and they will be busy. Inactive, if there is if machine is turned off, and then it's inactive, and then if machine is broken, it will be failed. So you can choose actually put the image for each state if you want it. All right, for idle, let's choose the appropriate image here. So I think that we can open the library. So here is if you go to the arena folder, and then so here, yes, under the Rockwell software. So users document Rakel software, and then arena and picture library. So if you go to the library, you can choose equipment. Okay, let's choose the equipment.plb file so that you can see the image of the machines like this. If you don't like it, and then you can also see the others as well. General, so general is image like this. So here, if I look at it, and then it's better to open the equipment. Yep. Long ago we have machines library as well, but let me just put the right one. No, sorry. So here, which one is better? Anyway, let me choose this image for the idle state, and then choose another image for the busy state. Okay, so and then if you click the OK button, and I can do this resource here, all right? And then here, if you go to the run, and there is a setup menu, and here is a replication parameter. So we will have a one simulation one, and then runtime will be 20 hours. Let me just run it for 40 hours and click OK. And then if you click this go button, and then you can see this graph over the time. And if you click yes here, and then you can see the result as well, report as well, but I will click no here for the explanation about this model. And here, if you look at it, yes, the image actually was changed, right, over the time. You saw that, right? So whenever it has a busy, when part sees a drill press, and then it was busy, and then when part released this machine, and then it was idle, right? And then there was a multiple number of entities over the time, right? Since we only run the simulation for 40 minutes, our simulation time is 40 minutes here, right? And then also here is a 40, right? And then if you look at it, about 41 entities were generated, and then still 3 entities are in the system, right? Maybe one of them are in the service, and the other 2 will be the queue, right? If you look at this graph, right? 2, and then also we have so 38 entities were left the system. Okay, so this is first example of the simulation modeling. So please develop this model, and then let me know if you have any question. Thank you.